it's Rich Tehrani with TMCnet. Thanks for watching. We're out here in Silicon Valley for Editors Week, specifically in Santa Clara, and we're with Thomas Chen. He is with Ambiq Micro. And Thomas, welcome. How are you?
Good.
So I'd like to start out generally with this question about like what your company does, where you fit in the market.
Great. So Ambiq Micro, we are a semiconductor company focusing on providing ultra low power solution for wearables and IoT devices. Really our goal is to be able to bring the power consumption down significantly to allow wearables and IoT device maker to be able to create new form factors or add new features and new capability and make the device much more useful and user-friendly.
So your solutions are low power semiconductors, low power chips?
That's correct. Yes, it's a low power semiconductor. Our current products are, we currently have two products. One is a microcontroller, one is a real-time clock. Both are extremely low power, we're 10 times lower than the closest competitor on the market today.
And for the microcontroller, is there a sleep mode that's even more efficient, something like that?
Oh, absolutely. You know, a lot of these devices today, they tend to be sleeping most of the time, and therefore our sleep power is optimized for these type of wearables and IoT application.
Very, very cool. So can you talk about some of the companies that that you work with or you've powered? I imagine you can't, but I'm asking anyway just in case.
Yeah, so we have some really, really strong wearable customers today. They're shipping devices like what I'm wearing today. These are a fitness tracker. And look how small they are.
Well, not only is it small, it looks really cool. It looks like just like a piece of jewelry almost.
Exactly. I mean, they had different accessories allow you to wear on your neck or put on your ankle and put on different parts of the body.
Can we ask who makes that, or?
Yeah, for this particular device, it's made by a company called Misfit.
Oh yeah, I know Misfit. Yeah. Sure. Their other one is like a small, like a button. Almost.
Yeah, like a button.
Yeah.
So actually, in fact, that's actually the story of it. Originally, they had to design with a button because of the battery size. Now with our solution, they're able to bring the power down, so they're able to fit in using much smaller battery and creating this type of new sleek form factor.
Sure. It's Sunny Vu, right? I think is.
That's that's correct. Yeah.
Great guy. So okay, very, very cool. So we have Moore's law. We all know what Moore's law is. Is there some corollary in the low power world where you're able to make things more and more efficient over time thanks to better silicon?
Oh yes, absolutely. I think one of the key technology we have, we call the SPOT. It's a short for sub-threshold power optimization technology. This particular technology we're the first one on the market ever be able to productize it. With this technique, any kind of electronic circuit, we can bring down the power significantly. And that's kind of how we founded the company on. And we'll continue to apply that to other parts of the circuit inside the wearables and IoT devices. And therefore, it creates great benefit for all the device maker to, like I mentioned, get smaller form factor, or they can actually use extra power budget to add more features, make the device smarter.
Now, what instruction set are people using to program? Like it's a microcontroller. Like, is it?
Yeah, it's a standard. Actually, it's a standard microcontroller. It's an ARM-based microcontroller.
Okay, that's what I was getting at.
Just like every other device.
Okay.
How you program it, except with our technology applying to this circuit, we're able to bring the power down significantly. Everything else is.
Okay, so you're applying. Okay, so let's see if I can understand. You're applying a technology. You're not redesigning the circuit. You're applying a technology to the circuit. Is it a different kind of?
Oh, it is at the circuit level.
So is it a different kind of transistor gates? A different material? Or?
Standard transistor gate, except the SPOT technology allows it to run at much lower voltage, and by doing that, now you're saving a lot of power. So traditionally, circuits are run at 1.8 volt. With our device, we're running at below 0.5 volt.
Okay, so that's a big difference.
It's a huge difference, and that has huge energy saving.
That's like what, 28% or something like that,
yeah.
Right?
Yeah.
So you're saving almost 70%, it sounds like.
It's actually, in a real world application, actually more than that. Depends on the use case. And on top of that, I mean, the problem running at such a low voltage is most circuit doesn't work. You know, we figure out a way to get that into the design and make it work properly.
Very, very exciting. So what else should we know about your company? Who are the kinds of people that should come to you? I guess hardware manufacturers, people who have an idea, entrepreneurs.
Yeah, absolutely. Any company that has some innovative idea about their wearables and IoT devices, they want to create new form factors, smaller form factor. They want to add more feature with the current solution can offer them the power consumption they need. Come to us, come talk to us about it, and we'd love to work with you to help you to create longer battery life and a more innovative form factor as well.
So the need for more battery life is not unique to wearables, right? We have the same problem in smartphones and laptops and tablets. I have to just throw that out there.
Yeah, absolutely. But however, in the difference between the smartphone and tablet compared to wearable and IoT is the battery size. Today, the smartphone tablet has much larger battery, and therefore, the power consumption that we can help them to save is not as significant as we will have in the wearable IoT devices. For example, in the wearable IoT devices, it could translate to 6 months turn into 1 year. But on the smartphone, maybe the power saving will turn to 2 extra day or 1 extra day.
And there's another reason for that I'm realizing now. The screen takes, you can't do anything about the screen, so.
Yeah.
So
Yeah.
I got it.
Yes.
Yeah. So the screen could take even more battery
That's
power
correct.
than anything else.
Yeah.
So.
Yeah.
All right.
Yeah.
Maybe someday down the road we'll figure that out too.
Yeah, absolutely. I mean, that's the goal of our company, right? We're starting with a wearable IoT because there's a immediate need for it to bring the power consumption down, and we can obviously apply the same technology to the smartphone and tablet devices later on, and that will be kind of our continuous goal to improve energy efficiency on all the electronics. Wearable and IoT just the beginning. I mean, we can do more than that. So.
Sounds awesome.
Yep.
So what else should we know? Anything else? Did we get everything?
Yeah, that's pretty much everything. And we're passionate about wearables and IoT devices. Like I'm wearing 2 myself. I mean, I got another one in my pocket. So, this is a new world. Everyone's going to have multiple devices, and our goal is to make sure that you don't have to charge it all the time, right?
Yeah, it's really fantastic.
Yeah. So you don't have to scramble to look for your adapter constantly. We all know how painful that is.
Oh,
so,
it's really painful.
yeah.
Really, really painful.
Yeah. And they cost a lot.
It does. It does. I was actually ordering new power adapters on the flight out to California because my other one broke, my old one broke, and I had to get new adapters. And that's another thing is these things last 6 months or a year, and you're always buying new ones. So
That's correct. Yeah.
if you don't have to use it as much, maybe it'll
last
longer.
much longer. Yep. Yeah.
So.
And that's really the ultimate goal. I mean, everybody talk about how big this IoT market is, right? To get there, you can't be charging all the time. So we're really solving that. To me, we're trying to make that IoT a reality.
Very exciting. Well, I appreciate you being here. It was great.
Yeah, same here.